Hello everyone, in this short video I'm going to explain sampling strategies. So for research methods, as we mentioned, we divided them into two large categories, qualitative and quantitative. Now within qualitative we have focused on case studies, interviews, and we do introduce the content analysis to analyze the textual data you gather from either case studies or interviews. Now, for quantitative, we focus on survey data analysis and experiments. So sampling strategies applies to both qualitative and quantitative methods because you need the sampling is because you either have a particular research purpose or you want to generalize your finding to be applied to the whole population, right? So since we said research methods is to help you find best answers to research questions, so sampling strategy is critical to both methods or mixed methods. Now, within the survey data analysis, we talked about how you can design your survey, right, and to respond to different levels of measurement, which are continuous numbers. Then we say, okay, this is either interval or ratio level of measurements, or if that's categorical, it's either nominal or ordinal, depends on whether or not it's ordered. So the sampling strategy have two large types: random sampling, which is commonly used for survey data collection, and non-random sampling, generally speaking, more commonly seen in qualitative study, but that's not definite, right? So it could be depend on your research question, research purpose, and other conditions. We will explain later, all right? So what is sampling? Why should we care? And how can we sample? So sampling actually refers to the process of selecting either people or elements, units to be included in your research. All right, so select a bunch of unit of analysis in your research. So let's see an example. This is after Hurricane Katrina. Right, so CBS News conducted a poll of 725 adults nationwide. So in the United States, right? So this is sampling, right? So sampled 725 adults in U.S. Now the other sampling method is a team of public health research surveyed 132 shelter residents at an emergency Red Cross shelter. All right, so now for the first one, nationwide, 725 adults, that's more likely to use a random sampling strategy. And this is nationwide, and this is representative sample. Okay, but shelter residents at a particular site, right? So even this is not a very small number. It's more than 100 residents, but this is a non-random, right? It's a particular site for people there, right? So this is like one emergency Red Cross shelter, but how about other shelters in other cities, right? So nationwide, it may not be representative. So why we sampling people, right? Because sometimes to study the whole population is not possible. It's too costly. Now, even for the United States government, they do census, right? So which include all the people in the United States. But that's very, very costly, right? So, and as an individual researcher, you probably won't be able to do it. And besides, that's probably not necessary, right? If you do it properly, if you select a random representative sample, you don't really need to do it because it has sufficient statistical inference power for you to generalize your finding. So generalization, or to generalize the finding from a sample to be applied to the whole population. That's the whole purpose of sampling. That's why sampling is so important. Now, to visualize the relationship, right? So we have, say, for instance, the larger circle. This is our population. Now we select a subgroup of people from it, right? So this is the small circle, right? We selected from the large circle. This is our sample. Now, why we need this sample? Because we are going to collect data from the sample, analyze them, and then make an inference, right? Because we suppose all the results from the sample is actually the same from the population. Now, then the other things we need to consider, right? The variety, the sample size, as well as confidence interval, etc. But the basic thoughts behind that is we want to generalize whatever we find from the sample to be applied to the whole population, right? So that's the basic idea behind sampling strategies. So let me give you another example. Sometimes, because to sample, you need to know your population at the first place. But sometimes population is not that easy to identify. All right. So this is a pretty old survey of in 2008 of 757 likely voters in Oklahoma. All right. So that survey found 54% say they prefer bring teacher salary up to the regional average instead of a merit-based pay system. All right, so if you look at this results, right, and it mentioned the 757 likely voters, but what's the population? What's the population in this case? Now, some people would say voters or adults in Oklahoma. But is this really true? Now, the population in this case, all right, we would say the likely voters. Now, likely is very vague. So that's why, sometimes the population is very hard for you to identify. So in 2008, Oklahoma has 3.7 million people in total. And within all of these, 2.4 million were eligible to vote. But remember this, we are talking about likely voters, right? Not all the people who are eligible to vote, they are going to vote. But we can look at the historical data, right? So within these 2.6 million, only 1.5 million voted in the last general election. Now, which means if we don't see a significant increase, so the number of voters probably going to maintain the same or smaller. Right, so the number of likely voters probably will be smaller than 1.5 million. All right, so now of course you probably see recently the trends will be different, but it really depends, right? So generally speaking, voter turnout rates is relatively low, not that high. Okay. So again, generalizability, right? So people would think, okay, now you mentioned different research methods. Are some of the methods better, right? As I said, there's no one method is particularly superior than the others. But from the sample to population, right? Is there anything we needed to know about generalizability? Now, first, for example, are experiments more generalizable? It depends on what, right? Depends on what you are looking for. If you are looking for the internal validity, then yes, experiments may be more generalizable. However, experiments, if you are only conducted with a specific, like a subgroup of people, that may not be generalizable to be applied to the whole population. Right. So, for instance, let me give you an example. Now, most of the social studies, if they are conducted in lab, they are using student participants. While student participants can guarantee the internal validity, but they are not guarantee you the external validity, right? Because students are so different from the whole population. So that's why you need to be cautious. All right, so can replication increase generalizability? Yes, of course, right? You replicate in with a different sample and do it multiple times, then of course it increases generalizability. So relationships, generally speaking, are more generalizable than absolute numbers. Right? So relationships, talking about the relations. So relations generally is more generalizable. Can qualitative findings be generalized? Of course, right? So we know in fighting malaria why some of the frontline health workers are not using advanced treatment kits is because they save for rainy days, they save for emergency, the information is inconsistent for them to use, and the people are more used to older drugs, etc. Right? And the mosquito nets is not being used for preventing mosquitoes biting their kids is because they are being used for fishing, etc., etc. So all these are qualitative findings, right? But you can generalize them to be applied from Indonesia to Bangladesh to South Africa to Kenya, etc. So yes, of course, qualitative findings can also be generalized. So let me give you one example when we talked about the relationship is more generalizable than absolute values. So let's see this chart. So this talks about relationship between health and happiness, right? So both are measured with scales. So health from 0 to 100 scale points, happiness the same. So it looked at all the nations and also looked at Moldova. All right, so this is from the World Values Survey. All right, so let's look at the all nations. So if you look at all nations, the health score on average is 71.8, while the happiness score is 69.1. Right, so the Moldova 50.4 for health, 50.9 for happiness. Right, so this is the absolute value. All right, remember this. Now, if you look at this, right, you probably will conclude that the Moldova people is actually like much different than the all nations average. Right, because when you see this, you would see, okay, the means of health and happiness, both health and happiness, on 0 to 100 scale points in Moldova much lower than the all nations average. Right, it's only like 50 something. However, if you look at the relationship, right, health and happiness relationship, the correlations between health and happiness. So all nations is 0.333, while in Moldova is 0.337. So which means they are probably very similar to each other, right? So Moldova is quite similar to all the nations if we look at the relationship between health and happiness, right? So if you only look at the mean values, you'll see Moldova is much lower, while if you look at the relationship, Moldova is actually not that different from all nations. So what conclusion can we see? Now, in terms of relationship between health and happiness, we would say Moldova is on average of all the nations. All right, so there's no significant difference between Moldova and all the nations. All right, so don't be fooled by only by looking at the absolute mean values. All right, so that's why we say, okay, the relationship is more generalizable. Right. So again, let's quickly reflect what we mean by sampling strategy. Right. So we look at a large population, then we select a bunch of them. Right. So to create our sample. And our hope is, okay, this sample is representative enough so that we can generalize our finding from the sample to be applied to the whole population. All right, so why? Why we explained, right? Because sometimes to study the whole population is not possible, and we can do it by statistical inference. We generalize our finding from a sample and to infer the larger population. So how can you actually select a sample? Now, first you define the population. Now, be careful, as we talked about the Oklahoma likely voters, right? Sometimes population is hard to define. But anyway, you need to identify a sampling frame that can represent the population, right? Then you select a subset of the units, contact them, record their responses, right, or the observations. Then you summarize them. Now, that could be two tables. One is descriptive statistics. The other is relational, right? Either correlation or regressional results. So there's two main types of sampling. One is called random sampling, also aka probability sampling, while the other is non-random. It's called non-probability sampling. So let's go back to the CBS and Red Cross shoulder survey after Hurricane Katrina, the example. So the first one is more likely to be a random sampling because this is nationwide, right? So this is more representative and more likely to use a random sampling strategy, while the other one is only on a particular site, right? So this is in a particular location, so probably cannot be generalized. So for instance, emergency Red Cross shoulder in New Jersey, you can't generalize the finding to be applied in Michigan, right? While for the CBS News, right, if the 725 adults nationwide more representative, that's the finding is more generalizable. Okay. So here's some common problems happened in sampling. The first is coverage bias, right? So now people use a lot of big data, right? So the online population generally say is younger than the whole population, because for people older, they tend to not use social media as frequently as the younger generation. So that's why if you only use big data and you don't consider the representativeness of your sample, then the results might be biased because the coverage is biased, right? You include less older generation than the younger ones. The other one is non-response problems. If you send out a survey, people are not responding, right? People didn't send them back, or if you send out survey link, people don't click it, right? They simply don't respond. Then you have non-responses problems. Well, the other one is for contact rates, right? So if you send out a large survey and most of the survey actually didn't reach to your participants, to your potential participants, then of course they are not going to respond to them, right? Even for emails, right? You send out emails and a bunch of emails end up in people's junk folder, then of course they are not going to respond to it because they are not seeing them. All right, so if you do have the non-response problems, then you probably will have two things. One is called positive bias, right? Positive bias, the first thing is called self-selection, because only people who are interested in your research topic will respond. Then you oversampled these guys, right? Because they self-elected into your survey. And which means you underrepresent, the others are underrepresented, other groups, right? So let me give you an example. If you are interested in women's rights, right, so then you send out a survey. Now it's very likely you need to over-survey a little bit the male respondents, because most likely women care more about their rights than men. So in your respondents, you probably have a very high respondent rate from women, while very low from the male. So you need to encourage a bunch of males to respond to your survey as well. Now the other one we will talk about is weighting, right? So if you have more female respondents in women rights survey, then you probably can weight it to be equal to the males. All right, so these are the technical statistical tools that we can use. Now the other thing is the random facts, okay, but that will not influence the outcome of your interests. For instance, some people don't respond it because of flu, because of some other like pandemic, right? So this will not bias the results. All right, so what kind of sampling strategies can we use and how can we use it? So sampling strategies, as we said, can be divided into non-random and random sampling. All right, so within the non-random, we have voluntary sampling, convenience sampling, snowball sampling, quota, online, purposive sampling, etc. Now, for random, we generally say we need a fair representation of the whole population. So we will say how you're gonna stratify it, or how you're gonna do different methods to actually select a representative sample of the population. So let's talk about the non-random first. So the first one I want to mention is voluntary sampling, right? So you just send out to recruit participants from mTurk or Craigslist, Amazon Mechanical Turk. So for mTurk, you actually need to pay a little bit amount to get your survey done. Convenience sampling. Now this is very common, right? Ask your friends, ask your classmates, ask your contacts, to fill out a survey. So that would be like, a convenient sampling strategy. And the snowball sampling generally used for vulnerable groups because these are groups harder to reach, right? So they are more sensitive. For instance, gang members. You don't tell all people around you are gang members, right? It's not that easy for you to contact them. So if you get one, then you ask him or her to introduce more to you, right? So this is kind of rolling a snowball. That's why it's called a snowball sampling. And quota is divided the population into groups using quotas, right? You can use age, sex, education background, etc., income levels, right? So online sampling, as we said, okay, this is very common nowadays, and you can even use companies to do it, right? So online companies like SurveyMonkey, Qualtrics, etc. And the purposive sampling. Now, there's one thing I want to emphasize here is there's a difference between purposive sampling and the snowball sampling. So the main difference between these two is that purposive sampling applies to all kinds of population, while snowball sampling is more specific. It targets vulnerable group of people, right? So vulnerable or harder to reach, right? Harder to reach. Generally, you won't see these people. But this purposive sampling doesn't have such requirements. So for example, you know people in a neighborhood who oppose a project, right? So then you want to know people on the other side who support the project, right? So that's called purposive sampling because you already know who oppose the project. You want to know who support the project and understand why, they understand their voice. So that's why you need a purposive sampling. But these people living in your neighborhood, right, they are not that hard to reach, all right? Well, for snowball sampling, as we said, like, street workers, gang members, people believe in rare religious and other things, right? So this is a difference. All right, so now let's talk about the probability sampling methods or random sampling methods, right? We talked about all the non-random sampling methods. So now for random sampling, you have multi-stage samples. So you divide into different stages. So for example, if you want to conduct a national one, right? So then you can divide it, first you assign a bunch of states, select a bunch of states, right? Then you select cities, counties, right? So then you select municipalities, then you select blocks, then you knock the door to house, right? So this is kind of multiple stage sampling. Well, the systematic sample is used, like for instance, if you are interested in students' opinion about university, then you send out of students' cafeteria, then for each of the 4 students, for instance, right? So you intercept, ask her or him whether or not they want to take a survey about their opinion about the quality of education, quality of the food, other services provided by the university, to understand whether or not they are satisfied with the university, etc. All right, so this is called a systematic sample. Well, simple random sample is just applied a very simple strategy. You can flip a coin to select it, or you use a computer generalized random strategy to select your participants. Okay. So remember this. Whenever you sample, right? So you have like population. You sample one time, sample the second time, sample the third time. Each time you sample, then something you didn't capture, right? So this is called the error. All right. So now we would say, let me give you an example. Okay. So for the first one, first sample, say, okay, you didn't capture the blue ones, right? For the second sample, you didn't capture the green ones. So anyway, there will be some like errors. All right. So this is called the sampling variability. All right. This is important because this is also related to how generalizable your findings from your sample to be applied to the whole population. Now, the other thing influences the generalizability is confidence interval. Now, confidence interval basically means how much you are confident that your population, all the parameters of your population is within the interval you created, right? So deficit setting, generally speaking, we use two standard errors, on both sides, right? So this is a 95% confidence interval, the level of your confidence, okay? So confidence interval, general rule is the larger the sample, all right, then the more precise the estimation, which means it's more likely for you to generalize it. While sample size is not the only fact influence precision, right? You also need to think about the variability. Remember this visualized sampling. If you sample and sample, you still lose, for example, the blue ones, right? You sample the first time, you get, for instance, a red one and a green one. You sample the second one. If you have two red ones, if you sample the third one, you have two blue ones, for instance. Okay, this is your sample. Now, obviously, you didn't catch the green ones, right? So then your conclusion, your finding from your sample cannot be applied to the whole population because you lost someone, right? You haven't included them in your sample. Okay, so which means each time you sample, the variability is huge because you lost something, right? So this means this is less precise the findings from your sample. All right, so now let's discuss the final thing, right? You probably want to know, okay, yeah, you talked about non-random random sampling strategy. So if I'm going to conduct a random sampling strategy, how large should my sample be, right? Now, there's no exact thing you can say, but the rule of thumb here is margin of error is 1 minus your confidence interval, right? So if you want a higher confidence interval, then you need a larger sample. That's the general rule. The relationship between these is like this, but you can calculate this. So for instance, if you want 97% confidence interval, which means 3% point margin of error, right? So you applied this equation to calculate it. So 97% actually means more than 1,000 participants. All right, 1111 to be precise. So let's say, how about 95% confidence interval? Now, first you calculate the margin of error, which will be 1 minus 95% confidence interval. That's 0.5, 0.05, sorry. So then you use 1 divided by 0.05 and take a square. That will be 400. Right? So 400 is the population, is the sample size. If you want to have a 95% confidence interval. So how about if you only need like a 90% confidence interval, then how many subjects you needed, or how large should your sample size be? Then you calculate the margin of error. This time 1 minus 90%, that will be 0.1. So 1 divided by 0.1 will be 10. Right, so then you take a square, that will be 100. Okay, so 100, you only need 100 of participants to have 90% confidence interval. But remember this, right? With the decrease or decline of your sample size, you are less precise about your estimation, right? So you are also less confident that you can say my estimation or my findings can be generalized, because you are not that sure all the population parameters is within your confidence interval of the sample, right? All right, so this is the general rule for calculating the sample size. All right, I hope through this short video you understand what is sampling. Sampling basically means select a subgroup of participation from your population. Now here the important thing is to define your population, right? So then you can select participants from this. And why this is important? Because you want to generalize your finding to be applied from the sample to be applied to the whole population or to other scenarios. That's why this is important, right? You don't have time, resource, energy, money, etc. to conduct the consensus research, right? This is just too costly and impossible for one research to do it. That's why you need a sampling strategy. And how can you do that, right? We have two general categories. One is called non-random sampling. The other is called random sampling strategy. All right. So finally, how can we decide, the sample size? Now, how large should your sample size be? Then you use this equation to calculate it, right? It all depends on how much your confidence interval will be. All right, that will be all for this short video. Thank you.